Hey there, it's Cindy Hunter, and this is the week 6 interactive advanced concepts video. So as most of you know, this is a totally different format. We are not actually doing an experiment this week. We are really just talking about nuclear fission and kind of how nuclear more or less how nuclear bomb works, so it's a little bit scary. But really the basis of this video is talking about what happens to actually give a nuclear bomb its power. So we're really just going to be talking about kind of how a nuclear bomb works and that why it's so powerful and so destructive. So really it's the nuclear chemistry we're really going to be talking about. So we all had to watch the video posted on Blackboard. That engineer talks very fast in that video. I only watched it through once, so I am going to try to remember the key points. There were things that came out in that video that really made an impact on me, so those are the things I'm going to kind of talk about. To start, let's talk about uranium. Let's just talk about how it naturally is occurring. It is in the presence of uranium ore. So uranium ore, I'm sorry, my dogs are in here and their collars are clinking. But uranium ore is composed of two isotopes, uranium-235 and uranium-238. So the important isotope that makes the biggest impact is going to be 235. So 238 just doesn't have, it doesn't split and have the same power or generate the same kind of energy that 235 does. 235 is really the one that we're talking about when we're talking about nuclear bombs, when we're talking about nuclear fission and that chain reaction. So what I really took away from the video was the engineer kind of talking about the separating process of uranium-235 and 238. So what he was kind of discussing was there's two types that really are used to separate these two isotopes, one of which is a series of centrifuges, so that the only difference between 235 and 238 is that 235 is slightly lighter, just because, as you can tell by the numbers, it's just got less of a composition, so it is in fact lighter. It has a lighter molecular mass. So because of that, when you're using something like a centrifuge, the heavier bits are going to swing to the outside when the rotor is spinning, and the 235 is going to be towards the center. So the way that it was showing in the video is that the heavier 238 would spin out to the piping to the side, and the central line at the top would more or less pull more of the 235 up and out into the next centrifuge, and it would just kind of keep going until hopefully you get all just 235, so you can actually make something with it. So the other method is heated gas. So just because of, again, the weight, the 235 being lighter is more likely to blow through those chambers and kind of be caught in some of the piping. So like the Manhattan Project is just, enormous, and it's just miles and miles of piping and these gas chambers. So that's the other method, is just like a heated gas sort of method. But anyways, so at the end of all of this, you end up with these this extracted 235 isotope, and the whole process of nuclear fission and how it creates energy is that, so you've got this nucleus, right? It is 235, and what we need it to do is to split. The splitting of a nucleus is how you're going to generate that energy. So you aggravate this nucleus of this one atom, let's say, of uranium-235. You throw a neutron at it. Just one little neutron, and this thing splits. And the splitting process of this 235 generates 2 more neutrons and the split atom. So that force, that energy that's created, actually initiates that chain reaction of nuclear fission. And every time that another one of those atoms splits in this chain reaction, more and more energy, it's exponential energy that's being created by every split. So just that one 235 atom is just creating this like this huge chain reaction of just massive energy. So that is kind of the idea behind nuclear fission, creating, you know, this bomb that creates enormous energy. So he had the tiny little atom bomb that was used for, I think he used the example of Hiroshima, but it's got this in the cylinder of this bomb. It's got this, I think he said maybe 60 grams, I believe, of uranium in the tip, and there's the projectile through the center of the cylinder to actually impact the uranium so that it would detonate. It's just amazing that if you've got just this small amount of uranium-235 and it hits on impact, it's just, it is absolutely catastrophic, the energy that can be made with a small amount of uranium-235, when what we were just talking about was one atom, and it can create just an enormous amount of energy. So that's kind of the idea behind a nuclear bomb and nuclear fission, and why nuclear warheads are incredibly powerful. So hopefully this has kind of helped explain everything. If not, there was another video, I can't remember what it was called, honestly, but there was one that I would recommend. All I can tell you is the guy was wearing a pink V-neck t-shirt, and it was a very well done video on nuclear fission. It actually helped me a lot with some of my homework. But again, hopefully this has been helpful, and my name is Cindy Hunter. Thank you for watching.